Alright, so position factors. A position factor describes the displacement from the origin to a point. For example, in the diagram, the position factor of P is OP. So in short, a position factor describes a factor from the origin. Okay, so here you should notice the word origin. So position factor are always represented as OA, OB, OC. Okay, because they start from the origin. Start from the origin, the point of intersection of x and y axis. So this is the representation of position factor. So anywhere you see writings like this that start with O, it means it is a position factor. Okay, any other factor that does not start from the origin is a displacement factor. So position factor OP, which is given the dimension 2, 3, 1, can be written as 2i plus 3j plus k. Okay, the displacement. Okay, so if you notice, position factor is also in displacement form. So you know from displacement, what OP means is P minus O. Okay, so the coordinate of P from here, what do we have from there? Coordinate of P is 2, 3, 1. Coordinate of O, you know O is at the origin, so that will be 0, 0, 0. So by the time you subtract, you have 2, 3, 1, okay, which is equals to 2i plus 3j plus k. Okay, so therefore we have that OP equals to 2i plus 3j plus k, so which still take the values of the position P. So position factor is a factor that starts from the origin, a factor that begins from the origin. So that's a position factor. Okay, alright guys, so a point with coordinate xyz has a position xyz, and in unit form we write it as xi plus yj plus zk. So if 2 point A and B have coordinate x1 y1 z1 and s2 y2 z2 respectively, then we have to describe the factors we're going to use displacement AB, which is b minus a. So this is b, or this is b minus a. Okay, so I believe you understand the difference between position factor and displacement factor. Okay, position factor start from the origin and the first letter is O. Right? Displacement factor start from a point. Okay, like A, B, P, Q, and then to find the displacement you do the second factor minus the first factor. Okay, alright guys. Example, find as column factors A, B, B, A in each of the following. So we've taken an example like this before, so I'm just going to let you do A as classwork, and then we look at B together. So B, so we have that A equal to minus I plus J, that's 0k, that's minus J. B equal to, put an arrow in place, B equals to 2i plus 0j minus 3k, so that AB will be equals to B minus A. Okay, so working this out, we have B is 2i minus 3k, okay, minus A minus I minus J. So if we do this, this will go to be 2i plus I, okay, plus J, minus times minus, plus minus 3k. And then if we do all together, we will be having 3i plus J minus 3k. And that is the final answer. Example 4. Find using a vector notation AB and BA in each of the following cases. Okay, so find using column vector. So we were asked to use column vector here, guys. So column vector AB will be equal to, in terms of column vector, that will be 3 plus 1 minus 3. 3, 1 minus 3. So that will be the answer. Then, so also, BA, let you understand something here. So do you know that BA equals to minus AB? Okay, let's find out. So you know that proof. So let's say proof. So you know that BA is equal to A minus B, right? And this is the same thing as if you multiply it by minus. This is the same thing as minus. If you multiply by minus, if you interchange it, this is B minus A, okay, which is the same thing. Are you following what I'm saying? Because if you open the bracket, we'll still go back to what we had there, okay, which is equals to minus AB. So this is shortcut of finding that, and this will be equals to minus 3, 1 minus 3, which is going to be minus 3 minus 1 and 3, and that is the answer. So this is how you can just use the logic to find minus BA. Okay, so make sure you do your classwork. Make sure you do your classwork. So find using unit vector notation AB and BA in the following. So we have the first one, B. So we are using column vector. So A is given as 4 minus 2, 8, and B is given as 12 minus 6, 1. So we have AB, which is B minus A, which is equals to 12 minus 6, 1 minus 4 minus 2, 8, which is equal to 12 minus 4 minus 6 plus 2, 1 minus 8, which is equal to 8 minus 4 minus 7. Okay, that is the final answer. So now let's take BA. So BA equals to minus AB, okay, and that will be equals to minus of our answer minus 8 minus 4 minus 7, which is equals to minus 8 minus 4, 7, okay, and that's the answer. Example 5. The position vector of a point A is 6i plus 2j minus k, and the position vector of a point B is minus 2i plus j plus 2k, okay? So find BA and AB. So let's see how many examples we have left here, okay? So let's just take one question there and leave it. So we have that B equals to 6i plus 2j minus k. That is, so that's A, that's A, that's A. And then B equals to minus 2i plus j plus 2k, okay? So the position vector, or the displacement vector of A, which is BA, because you know that would be A minus B, which is equals to vector A, 6i plus 2j minus k minus vector B minus 2i plus j plus 2k. So subtracting that, we have 6i minus times minus is 2, minus times minus is plus, plus 2j, this is minus j, plus minus k minus 2k, and that will be equals to 8i plus j plus j minus 3k, okay? And then of course the other one, AB, AB will also be equals to minus BA. Okay, so we can use that to compute our answer. So AB, that is B, AB will be equals to minus BA, which is equals to minus 8I, we have the 8I plus J minus 3K. And that will be equals to minus 8I minus J plus 3K. So this is how you work with vectors. So alright guys, so in this lesson we've looked at vector notation. So as a form of summary, so in this part of the lesson we looked at vectors, we looked at scalars. Okay, we talked about vector as object with magnitude and direction. Okay, talked about scalar as object with magnitude only, no direction. Okay, so we also talked about position vector as an vector from the origin, and the representation can be OP. Okay, we talked about displacement vector. Look at displacement vector. So displacement AB equals to B minus A. Okay, and then we've also looked at one important parameter, that AB is always equals to minus B minus BA. Okay, so this is what we've considered in this lesson. So